decimals and take a look at the graph here first. So in decimals, what's the left side say there, kids? Is it square root of x plus 6? Is that right? Is that what I remember? X plus 6, and then outside of that, is it minus 1 or plus 1?
Plus.
Plus 1? And what's the right side telling us there?
Square root of 7 minus x.
Square root of 7 minus x, like this. Okay, it looks like it crosses in how many points, kids? So it looks like there's one solution. So if I look at the one solution, looks like the x value is going to be what here, kids? -2, okay? Let's see if we can't work our way through this algebraically, apply what we know, see if we can't solve this, all right? So here we go. So what I'm going to do, I'm going to start by squaring both sides on this here, all right? So we're going to square on the left, whoops. And we're going to square on the right, okay? Now the right side's pretty easy because that's just a radical by itself. What's the right side simply going to become now? 7 minus x, you bet. Okay, the part that's going to be tricky though is trying to square this. Okay, and I'm going to help you. You guys agree that squaring this means take this times itself? So if I go to a new page here, that really means root x plus 6 plus the 1 times root x plus 6 plus 1. Okay, so help me out. What's root x plus 6 times root x plus 6? Or root x plus 6 squared, if you will. It's just x plus 6, right? That root times itself is just going to be x plus 6 to start with. Now, this is where things get a little goofy. What's the root of x plus 6 times 1? Well, it's just plus x root 6, isn't it? Agree with that? Okay, what's the 1 times this root x plus 6, kids? And then finally on the end, kids, 1 times 1. That would just be 1, wouldn't it? Okay. You guys agree that this becomes the x, this part. How many of these root x plus 6's do we have? Two of them, right? So plus 2 times the root of, that's what those combine to. And then how about the 6 and the 1 on the end? What's that going to combine to? So the left side is going to expand to x plus 2 root x plus 6 plus 7. So I'm going to put that on the left side here. This is going to be x plus 2 root x plus 6 plus 7. Now kids, help me out here. I've gone from 1 root down to what? I'm sorry, I've gone from 2 roots down to what? 1 root, I'm sorry. Okay. Everybody understand how I got this right here? Any questions about that part of it right there? Okay, so we start applying our rules and say, boy, it would really be good if we could get what all alone on the right, or I'm sorry, the left side now. Try and get this root alone, okay? So help me out here, guys. I can subtract how much from both sides first? Okay, this is interesting because what do the 7's do here? And what do they also do right here? So we have x plus 2 times the square root of x plus 6 equal to negative x. Okay? Let's keep working ahead to try and get rid of that stuff that's preventing us from having this radical alone. So could I subtract x from both sides now? Yeah. So these are gone. So this is 2 root x plus 6 equals negative 2x on the right. What do you want to divide everything by now, kids? Divide everything by 2, so we have root x plus 6 equal to what?
Negative
Negative 1x, right? What's my next step now? We're going to square this, right? So, right here, let me make some room for this next step. Okay, if I go ahead and square everything now, right here and here, if I square everything now, oops. What are you going to get on the left side here, kids? How about negative x times negative x? Wouldn't that just be a positive x to the second? Ooh, so we're at that point where we're working with quadratics again, aren't we? All right, so quadratics are only going to work when we have the form ax squared plus bx plus c equal to what value? 0. So is it okay if I move these to the right? So if I have 0 on the left, that's going to equal x squared. How would you get this x to the opposite side?
minus x minus 6.
Are you with me so far? By graph, we know they're going to intersect, and the x value is going to be what value? Negative 2, right? All right, so I'm going to go quadratic formula calculator here now. And let's talk about this. So in my quadratic formula calculator, let me find that quickly. Okay, what's the a value I'm going to plug in first, kids? One, you said? What's b? What's c? Okay, so we've got an answer of 3 and what else? Okay, so it looks like the x value is by a quadratic formula calculator, so I'm going to go in here and I'm going to say, you know what? By quadratic formula calculator, x equaled negative 2, x equaled 3. So let's talk about this, kids. We talked about sometimes we're going to get answers when we go through the mathematical process of setting up our problems. And when we go through that process, sometimes we get answers that work, and sometimes the answers, if I plug them back in after I check, will not work. What do we call those answers that we throw back in that do not work? Remember that word yesterday? Extraneous solutions, okay? Let's check the negative 2. Now again, understand we said if this root is like this up here, especially in this case square roots, we are assuming they're what type of square root? Positive or negative? Positive. So let's plug stuff in. Let's plug the negative 2 in. Here on the left, this will become root negative 2 plus 6 plus 1. We want to know if that equals square root of 7 minus negative 2. Help me out, kids. What's negative 2 plus 6?
4.
Square root of 4 would be 2 plus the 1. 3 on the left. Help me out here. What's 7 minus negative 2 here? What's the square root of 9? Hey, we got a comparison, 3 equal 3. Is that a good comparison or not a good comparison? This is good. So x equals negative 2 is a solution. Okay, x equal negative 2 is a solution, right? So that means we have to check what now, kids? We knew by the graph. We knew by the graph there was only one point of intersection. We've just shown that negative 2 works. So what do you think 3 is going to be? Let's check it out. Let's see what happens when I throw 3 in here. So this becomes the root of 3 plus 6 plus 1 equals the root of 7 minus 3. Hey, help me out on the left side. What's the left side going to equal after I've substituted 3 in that we think might be a solution? Comes the square root of 9 plus 1, doesn't it? What's that going to be on the left side? 4. What do you get on the right side? 2. Ooh. Is that a true statement or false statement? This is false. So x equal 3 is what? What's the word I want to throw up here? X equal 3 is extraneous. You bet. Guys, how many roots did we start up with up there? 2. We said it's probably a pretty good idea to do what to both sides right off the bat? Square both sides. Squaring both sides took an equation with 2 roots down to an equation with 1 root. And then once we had that 1 root, we applied our previous rules, isolate that, square again, took us to a quadratic. We got a couple of solutions. We've said in this section, when you get solutions, make sure you do what? Check, because not all of them are going to go back in and make things true, okay? I would also advise you graphically. You might want to put stuff in graphically to look at it visually so you can see exactly what's going on there, okay? Questions so far, kids? Fired up today, hey? Alrighty then. Let's go on to the next example. Guys, we're going to start looking at solving equations with what? Okay, instead of having all the radicals out there, we're going to start throwing some fractional exponents up there, kids. And when they do that, it's not too bad. Guys, remember what reciprocals are? What's the reciprocal of 2/3? 3 over 2, right? Okay. Anytime we talk about solving an equation with rational exponents, those exponents are going to be kind of a fractional form. I'm going to make a note up here. I want you to think this way. Think reciprocals. I'll show you what I mean and how to solve this. Think reciprocals. Here's how this works, kids. So solve 3x to what power, kids? The 3/4 minus what? 2. Equals. Okay. Much like radicals, where you're trying to isolate a radical, rational exponents, you're going to do kind of the same thing. You're going to try and isolate any term that has a rational exponent in it. So really what I'm going to try and isolate here is this 3x to what power, kids? So anybody have a guess where I might start to try and isolate 3x to the 3/4 power? What might be your first step to trying to work with this? Add how much? 2. We're going to get rid of this minus 2 here because this minus 2 has nothing to do with that power. The only thing we're taking to the 3/4 is what? Okay, so let's do that. Let's add 2 to both sides. Let's see what happens. We end up now with 3x to what power, kids? Equals what value? Okay, this is where things get kind of important for us. Okay, in red here, guys, to make that 3/4 go away, what we do is we end up saying, let's take this now all to the 4/3 power. Okay, some of you are saying, well, why do I go 4/3? Well, here's the deal. What's 3/4 times 4/3? In other words, what's the 4 times 3 on top when I bring that in? What's 3 times 4 on the bottom when I bring that in? What's 12 over 12 make? So the product of reciprocals is going to be what value? So this just really turns into what here on the left? Well, 3x to what power? 1, or just 3x. But if I take the left side to the 4/3 power, I better darn well do what to the right? Take this to what power? Okay, somebody evaluate 27 to the 4/3 power for me. 81? So this becomes 3x is equal to what value, kids? 81. You want to solve that now? Divide by? Yeah. Talk to me, kids. What's your solution here?
27.
X equal 27. You bet. So kids, much like radicals, where you were saying, let's try and isolate the radical to one side and then work with it, we are trying to isolate anything with a rational exponent. So in this case, I wanted to get this part alone right there. If I can get that part alone, then we can work with it. How are you going to make a fractional exponent go away? We're going to raise it to the reciprocal of the power that's already there. Does that make sense? Okay, let's see what lies ahead here. Solving an equation with a rational exponent. You know what? You guys talk me through this. Okay. Let me size this down a little bit. Let's see where we're at. I'll go back up there. Okay. What's my rational exponent here, kids?
1/2.
1/2, right? Is the expression raised to the 1/2 power isolated already? It is. So what am I going to do to both sides right off the bat? Raise it to what power? If I do it to the left, I better do it to the what? Okay, help me out here, kids. What's x? What's the 2 and the 1/2 really going to kind of do to each other as exponents, as rational exponents? What are they going to do to each other? They're going to kind of cancel. So what expression are you really going to have left on the left side? X plus, what are you going to have on the right? X to the, oh, okay. Ooh, this looks like what type of a problem again? Looks like a quadratic. We better make it equal what?
0.
So how do you want to write this, kids?
0 equals x squared minus x.
You guys have it. 0 equals x squared minus x. Okay, so let me pull the calculator. Will you guys be willing to help me plug A, B, and C in here? What's A? 1. What's B? -1 again? Oh, okay, so what's the C value here? All right, so let me get my... -12, you said? What is that noise? Anybody know what that is? All right. All right, what do we get for solutions, kids?
4 and -3.
4 and -3. Okay, so we're just done, right? When I say 4 and -3? Who said no? Say it again. We gotta check. Gotta check. So we think our solutions are, what was it? 4 and -3, was that right? X equal 4, x equal -3. All right, let's chat, kids. If I go back into the original function, what is 4 plus 12, kids?
Mm.
16, and then 16 to the 1/2 power for me.
4.
So on the left side, I go 4 plus 12. To the 1/2 power equal to 4. You said this is 16 to the 1/2 power. This is 4 equals 4. X equal 4 work? So this one is okay. What do you think is going to happen with negative 3? Well, let's check. What's negative 3 plus 12, kids? What's negative 3 plus 12? 9. 9 to the 1/2, or the square root of 9. We're really going to call it what here in this case? Ooh, is this good? Nah, it's not good. That's a problem. So is this okay? Not okay. What are you going to call this? Extraneous. So really the value here should be what? What's your solution? What's your solution? Yeah, you guys know what you're doing. You guys get this exponent part, how to get rid of rational exponents, make them go away. Again, isolate anything with a rational exponent, make it go away by raising it to the reciprocal of that rational exponent. And you're kind of on your way there. All right, so let's see what's ahead here. Any questions about anything on that page, kids? Mandy, you might need to just get something. We'll get it from her when we get done here. You okay with that, bud?
Yeah.
Okay. So I think we have one more example. Is that right, kids?
Yeah.
Okay. So let's run through this, make sure we're cool with it, and then I'm going to get you a short, quick quiz, and then I think I sent the book page out already, didn't I?
Yeah.
So that's all you're going to have assignment-wise today. Fair enough? Okay. Solving a radical inequality. Same exact properties, kids. The only thing that's different here, instead of having an equal sign, you have what? Have a... Okay, let's go. What are you going to do first? What do you think you're going to do? Add 4. Okay, here we go. Okay, so I've got 3 root x less than or equal to. Does adding change the direction of an inequality sign? No. So this will be 12. What do you think you're going to divide by next?
3.
Divide by 3. So this is going to make square root of x less than or equal to what? 4. What are you going to do to both sides now? So x is going to be less than or equal to what? 16. Now I want you to be careful on this here because I want to make sure that they address this with you guys. I'm pretty sure they do. Kids, can square roots ever have a negative number underneath the square root sign? Can there ever be a negative number under? There can be, but we call them imaginary numbers, don't we? So I want to check something here real quickly. I think you need to consider this right up here. Okay. Up here, your radicand right here is square root of x, right? Now I get that x has got to be any value less than or equal to what? 16. But when we talk in terms, and we're talking only in terms of real solutions this time, kids, we need to consider this square root of x. So step 1, solve like normal. This is all step 1 over here. Now for inequalities, there might be a step 2. And this step 2 is to consider what's underneath the radical sign to begin with. Consider your square root of x, kids. Okay? You don't want this to be what kind of numbers? Negative. So what's the absolute smallest number you could consider putting in for x? 0. Okay, so x, and this right here, I'm going to say x is going to have to be also something greater than or equal to 0. So it looks like the values that work in this inequality, you can be as high as what value, kids? 16, and anything lower than that all the way down to what? 0. So the way we write our solution for this, kids, we say, you know what? We're picking x values that range from 0 to 16. In other words, we want x values to be less than or equal to 16, but we also want these x values to be greater than or equal to what?
0.
Okay. So I write it like that. I put my small value on the left, my larger value on the right. And that would be one way of solving the inequality there. Okay? So I'm not going to get too wrapped up in inequalities. I kind of want you to understand that, again, step 1 when we follow the rules, yeah, we get x is less than or equal to 16. We get that. But we also need to consider what the original problem had in there as a radicand. Since we were talking square roots, that meant, you know, negative numbers are smaller than 16, but I can't put negative numbers in there. So that's why I've got to put that limit of 0 here. Does that make sense to you guys? Give me some sort of sign that you get that. Okay. Any questions today? Once. Twice. Let me stop the recording.